Good morning, students. Myself, Malika Mansupriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W25601, Basic Electrical and Electronics Engineering in the Regulation 2025. Today, we are going to learn an important topic, which is a series and parallel RLC circuit. In previous classes, we studied resistor, inductor, and capacitor individually. In this session, we will see how these components behave when they are connected together in a circuit. So, briefly connect this previous knowledge. Understanding the RLC circuit is very important because they are widely used in electronic systems like filters, communication circuits, oscillators. This is the this helps to understand the importance of the topic. Next, what is the definition? The series RLC circuit. A series RLC circuit is formed with three electrical components, that is the resistor, inductor, and capacitor, are connected in series, meaning one after the another in the single path. That is means a series. So in the series circuit, there is only one path for the current to flow. So same current flows through the resistor, inductor, and capacitor. So you can imagine it like a water flowing through three pipes connected one after the other. Since there is only one path and the same amount of water flows through all the pipes. Similarly, in a series circuit, the same current flows through all the components. Since the components are connected in series, what will be the same in all components? Voltage or current is the same for all the components. So in electrical engineering, we mainly deal with two types of the circuits. One is AC circuit and another one is a DC circuit. In AC circuit, the current changes its direction periodically. So in AC circuits, it mainly consists of four important elements. The energy source provides electrical power. The resistor, which is used to oppose the flow of current. Inductor is used to store energy in the magnetic field, and the capacitor also stores energy in the electric field. So to analyze the AC circuit, we use Kirchhoff's law. This is very important. So, which are the same laws studied for the DC cycle? How we can remind them? The Kirchhoff's current law is sum of current at a node is zero. What is the Kirchhoff's voltage law? That is KVL. Sum of voltage in a loop is zero. Next one is the fundamental of series RLC circuit. In a series RLC circuit, the resistor, inductor, and the capacitor are connected in a single loop. See this diagram. This R, L, C are connected in a single loop. Each component opposes the flow of current in a different way. So explain one by one. The resistor opposes the current by the resistance, and the inductor opposes the change in current using the inductive reactance, that is XL, and the capacitor opposes the voltage change using capacitive reactance, that is XC. When resistance and reactance combine together, the total opposition of the current is called impedance. So XC plus XL is equals to, that is the impedance Z. So is an AC circuit, we use impedance instead of resistance. In DC, we are always using the word resistance, but in AC, we are using the word impedance. So the important thing is Z is equal to, that is the impedance. The Z is equal to square root of R squared plus XL minus XC the whole square. That is resistance squared plus the inductive reactance minus inductor capacitive reactance the whole squared. So next one is the parallel RLC circuit. In a parallel RLC circuit, the resistor, inductor, capacitor are connected parallel to each other across the same voltages. Here, the current only are different, but the voltage is having the same. So, in this case, the voltage across all component is same. The current is different in each branch. So, the current from the source split into three branches. This see the current from the source IS, the voltage is all even for the R, L, and C. But the incoming current, that is the source current, IS is different from the one through the resistor, that is I current, and one through the inductor, that is IL current, and one through the capacitor, that is the IC current. So what does mean that the source current, which is divided into three equal parts, three parts, which is pass through the resistor, inductor, and capacitor. Since the currents are not in the same phase, we cannot simply add them normally. Instead, we use the vector addition of phasor addition. So, what is the vector addition, phasor addition? We are discussed in future class. And the next one is the applications. In this application, the parallel RLC circuit are very useful in the electronic systems. First one is that it acts as a tunable circuit. The circuit help in selecting a particular frequency. For example, the radio receiver. We tune the particular station. No, in that we are using this parallel RLC. That is the RLC circuit. Next one is the filters. Filters, they can act as a filter such as low pass filter, high pass filter, band pass filter, band stop filter. These are the filters we are using the parallel RLC circuit, and this filters allows a certain frequency and block the others. The next one is the oscillators. Oscillator means RLC circuits are used in the oscillators, which generate continuous signals used in the communication system. And the next one is the amplifiers and the pulse circuit. They are also used in the voltage amplification and the pulse circuit in electronic devices. The next is the problem. In this problem, a series RLC circuit containing a resistance of 12 ohm. This is the resistance value, that is of 12 ohm, and the inductance of 1.5 Henry. In this is the inductor having a value of 1.5, 0.15 Henry, and the capacitor value is 100 microfarad. So these are all connected in the series, and the source voltage is 100 volt with 50 hertz supply. What they are asking, calculate the total circuit impedance, that is Z, and the circuit current, that is total current I, the power factor. What is power factor? Phi. Draw the voltage phasor diagram. So in the solution, we already know about that inductor, how we are finding the impedance. Z is equals to, what is the value? What is the formula? Square root of R square plus XL minus XC the whole square. So we have to find, we have the value of R. We have to find the value of XL. We have to find the value of XC. So what is the formula for XL? 2 pi FL. F is the frequency. They are already given. So 2 into 3.14 into that 50 frequency into the inductor value 0.15. So we are multiplying this. We are get the value XL. And for the XC, the formula is 1 divided by 2 pi FC. We are having the capacitor values 100 microfarad. So micro means 10 to the power of minus 6. So we are substituting the same values and we are getting the XC. So we found the XL and XC. Now the impedance, that is equal to square root of R square plus XL minus XC the whole square. What is the value of resistor? They have already given 12. So 12 square plus, if we found the value, no, XL and XC, we substitute the value in the circuit impedance. So what is the value of Z? That is 19.4 ohm. We have to put the unit is ohm because in AC, we are telling about the resistor into the impedance. So we are substituting the unit as ohm, and the total circuit current is I is equals to V by Z, because V is equals to IR, no. So I is equals to V by R. Here R in the place of impedance Z. So V in the place of the supply voltage Vs. So the supply voltage is 100 and the impedance value is 19.4. So we are getting the value, the total current is I. The next one, we have to find VR, the individual voltage across the resistor, inductor, and capacitor. So V is equals to IR, so I into R. Then VL is equal to I into XL. That is R. XL means the inductive reactance. So I into XL. VC is equals to I into XC. So we have find the value of VR, VL, VS, VC. Then we are finding the power factor and phase angle. The formula is cos phi is equals to R by Z. First, we have to find the value R by Z, and then we are finding the value about phi is equal to cos inverse of the value. So it proves the value in the 51.8 in the phase of lagging. So this is the example problem for this parallel RLC circuit. So in this session, we studied the series RLC and parallel RLC circuit, their structure, characteristics, and applications. These circuit and one more example problem. These circuits are very important in electrical and electronics engineering, especially in communication and signal processing system. We next move on to the next topic in the next session. Thank you.